Hi, everyone. We're going to go ahead and go through units 1.3, midpoint and distance. I'm basically going to just kind of summarize each piece of this, jump over to the practice problems, go ahead and knock out some of the practice problems or all of the practice problems for you, and then wrap it up. So you'll notice that we're skipping 1.2. So the district has come up with certain lessons they want to keep, certain lessons they want to bag. 1.2 was one of the ones they wanted to toss. So we are jumping to 1.3, midpoint and distance. This is a pretty straightforward topic because there's two things it's really asking you to do, and I believe both things really give you a formula for it. So this should be a pretty straightforward lesson. The first thing is talking about midpoint. So the midpoint is basically if you have a length of something, a line segment, right? A segment of something, some distance. If you want to find the midpoint, it's basically finding the point in that distance, in that length, that's perfectly right in the center. So take this example from example one. If they give me that line segment right there, if I found the midpoint, it would land perfectly in the middle between A and B. So in midpoint, you'd use this formula. The X value of your formula for the midpoint, if you added the two X values of your points together and divided it by 2, that would give you your X value of your midpoint. If you added the two Y values of your points together that make up your segment and divided it by 2, that would give you the Y value of your midpoint. You might notice some notation here. They read this X sub 1, X sub 2, like subscript, because it's kind of written lower than like X squared. So X sub 1 just denotes that it's one of your X values of your 2 points. So for example, these 2 points, it doesn't matter which one you call point 1 or point 2. I guess for the sake of argument, since A comes before B, we'll call A point 1 and B point 2. So this would be X sub 1, and then I'd add X sub 2, the 4. So -3 plus 4. And then when I do my Y value, my Y sub 1, which is 2, and then I'd add my Y sub 2 from point 2. So 2 plus -2, that's how that works. That's what that notation means. So example 1 is walking you through that exact same thing. You can see what they're doing here, which is exactly what we just talked about. Take one of my X values, added it to the other X value from the other point, divide it by 2. Take one of my Y values, add it to the other Y value, divide it by 2, and that gives me that midpoint. So in this line, A to B, 1/2, 0, which looks like it would be about right there, is the midpoint. That's halfway between A and B. Example 2. Partition a segment. What are the coordinates of the point 3/5 is away from A to B? So you might think, well, can't I just measure that and measure 3/5? So somewhere maybe around up here, right? Not really, because you're not looking for the actual measurement that's 3/5 the way up. You're looking for the value or the point value, the X and Y coordinate that's 3/5 the way up. So it's a little more complicated than that. So what they're doing is they're breaking it down between a horizontal change and a vertical change. So in this example, they're taking 3/5 and they're going to multiply it by the difference from point B to point A. So if I'm talking from A, because I think that's what the problem said, find 3/5 of horizontal and vertical change from A to B. So that's important. You're going from A and you're going this way like a vector, right? You're going that direction 3/5 of the way. You got to make sure you're following that. Because if you started with B and went 3/5, you'd be down here. So the way that works, horizontal change, I take my two X values and I'm going to subtract A from B. So I take B, which is 13, and I subtract my A X value, which is 3. 13 minus 3 is 10. And if I multiply that by 3/5, because that's how far they want me to find it, how far it is away from A, 3/5 the way from A to B. If I multiply it by 3/5, that means that change is going to be a change value of 6. That doesn't mean that the X value is 6 for our point that we're looking for. This is just saying that the change is going to be 6. Same thing with the vertical change. I want to multiply that vertical change by 3/5 because I want to find 3/5 of that way. So I'm going to take the y value of b, subtract it from the y value of a. So 11 minus -4, which is 15. So 3/5 times 15 is 9. So the vertical change is going to be a change of value of 9. So that's important. That's not your x and y. It's not like the point that's 3/5 away from a to b is 6, 9. That's not the case. This is just how it's changing from a to b. It's changing by a value of 6. It's changing by a value of 9, horizontally and vertically. So the next step they want you to do is to take that point A, because again, that's where you're starting from. You're going from A to B. So I need to take that x value and add it to the horizontal change, which is 6. So 3 plus 6 is 9. Take that horizontal change, add it to my y value. So -4 plus 9 is 5. That gives me that new coordinate point. Okay, that's 3/5 of the way from A to B. So find the horizontal change, take the two values of x from point B, or I'm sorry, from point A to point B. You're going to take B, subtract it from A, and then multiply it by 3/5. Same thing with the vertical change. You're going to take your B value, or you're going to take your value of y from your B point, subtract it from your value of y from your A point. And when I do that, I get 15, multiply it by 3/5, that gives me 9. So that's how those points are changing. So 3, -4, 3, I add 6, I get 9, -4, I add 9, I get 5. So that point 3/5 of the way from A to B is 9, 5. Example 3, derive the distance formula. And again, this should all look familiar to you. You know, we haven't specifically talked about this, but you've been introduced to this in the past. Distance formula is just kind of saying what is the distance from point A to point B. You could just plug it into this formula. And we already talked about what x sub 2, how to read that, right? X sub 1, y sub 2, y sub 1. You're basically taking the x and y values from two different points. You're subtracting the two x values, squaring it, subtracting the two y values, squaring it, and then you're going to add those together. Okay. After you add them together, you'll notice that there's a big square root above it. So you'll take the square root of that number, and we'll do an example of that here in a little bit. Again, they just give you that distance formula up above example 4. Example 5. So this is just applying the distance formula. So taking that formula they give you right above example 4 and using two values. In this case, I think they're asking you, a pitcher throws the ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between the batter and the shortstop, what is the total distance traveled by the ball? So the batter is at 0, 0. The shortstop is at 5, 10. So what's the distance between 0, 0 and 5, 10? Obviously, you can't just count it because, right, you're not going in a straight line like you would be if you went left to right. That's a different story. If I said, what's the distance between the batter and the first baseman, you wouldn't have to apply that distance formula. You're just like, oh, it goes from 0 to 10. So it's 10 units, right? Or in this case, 1 unit is 9 feet. So it's 90 feet from batter to first baseman. But if you go from batter to shortstop, you can't count it out like that. You have to use the distance formula, which is what they're showing you down here. So make sure you walk yourself through that distance formula. Make sure they didn't make a mistake in the book. And then the concept summary. Remember, this is a page towards the end of the lesson each time that's going to summarize what it talked about. So it gives you the midpoint formula, the distance formula, and then it gives you an example of what they're talking about. So for my notes, that's essentially what I wrote, exactly what the summary had. Midpoint and distance. The midpoint just splits that segment in half. So make sure you have these two down in your notes, because unless you just memorize them, that's super important to know those because you will be applying those this week. All right. So this week we are problems 15 through 22 on page 26. 15 through 22 on page 26. So I'm going to walk you through each of these, and I was about to say take any questions, but obviously this is a video, so I can't take questions. So I'll walk you through these problems, and then we'll wrap up. Number 15. Find the coordinates of each given point on line segment AB. So if you look there, they have a line segment that goes from A to B. They're giving you the point values. If they didn't give it to you, you could find it as well because it's on a coordinate system, but they give you those point values as well. So 15, the point 3/10 of the way from A to B. Again, that's really key that you're catching that. It's going from A to B. You want to go 3/10 of the distance starting here that way, in that direction. Because if you look at 16, that's the other way, right? They want you to go a quarter of the way from B to A. So it's important that you understand that you're going a certain direction. There's a vector here, is what they call it. Number 15, the point 3/10 of the way from A to B. So what I need to do is find how that is changing for each of those points. So it looks like point A is -4, -7. Point B is 12, 5. And this is number 15. So I know this is changing horizontally. If you forgot, right, let's just imagine that you don't remember what this is talking about. You're like, what am I doing? Am I multiplying one thing by 3/10? I'm not sure what's going on. Don't forget, all these practice problems always reference an example. So if you don't remember what you're supposed to be doing, just go back to example 2. We actually walked through this one. Example 2. This is the one that we were talking about. You got to find that horizontal change, then that vertical change, right? Then you take those two changes and you add them to your X and Y points. Okay, horizontal change and vertical change. So this is changing horizontally. I'm going from A to B. So I'm going to do 3/10. Since I'm going from A to B, I'll start off from 12, subtract -4, and that's going to give me 12 minus -4 is 16. 3/10 times 16. So that is going to be 48. 48 divided by 10 is 4.8. So 4.8. So I know that my horizontal change, right? Horizontal change, that's not the new X coordinate. That's just how it's changing from A to B. It's 4.8. Okay. And then vertically, I'm again going 3/10 of the way. So vertically, it is 5 minus -7. So 3/10. 5 minus -7 is 12. 3 times 12 is 36. 36 divided by 10 is 3.6. So this is my vertical change. All right. So I got a horizontal change and a vertical change. Now I just have to add these to the point that I'm going from. Again, I'm going from A to B. So I'm going from -4, -7. So I need to add those changes to that. So the horizontal change, that's another way to say X. Vertical change, that's another way to say Y. So I'm going to add 4.8 to -4. So that's going to be what? 0.8. I don't know why I put a parenthesis there. All right. So -4 plus 4.8 is 0.8. And then -7 plus 3.6 is -3.4. So that is my point that is 3/10 of the way from A to B. And I can kind of go over here and visually check it. If I go over 0.8, let me get something other than a marker here. If I start at my origin and I go over 0.8, which is about right there, right? I don't know, something about right there. And then down 3.4. So 1, 2, 3, 3.4, something about right there. I don't know. That matches up, right? It's not like we're like down here or we're up here or something like that. That's about hitting that line. So I'm comfortable with that answer. Of course, if I didn't know if that answer was correct, I could always go back to the answer key in Canvas, and I can just double check it, which I highly encourage you to do. So make sure you have that answer key open and you're double checking that. Number 16 is very similar. Same thing that we just did, but now we're going in the opposite direction. So for this example, let me get a fresh piece of paper. Now I'm going from B to A. I want to go 1/4 of the way from B to A. So my value from B to A is going to be 1/4. -4 minus 12. And then the other one is going to be 1/4. It's going to be -7 minus 5. So if I simplify this, 1/4, -4 minus 12 is -16. 1/4 times -16 is -4. So I know that that's my horizontal change. 1/4, -7 minus 5 is -12. 1/4 times -12 is -3. So I know that that's my vertical change. Remember, the key here is you're going from B to A. So I'm not starting at A and moving that direction. I'm starting at B and moving this direction. So I want to take these changes and I want to apply them to point B, which is 12,5. So for 12, that's going to give me 8. So that is my X value. And then for 5, I'm going to subtract 3, and that's going to give me 2. That's my Y value. So my new point is 8,2. Again, let's go verify that it's correct. If we're off the graph, this is just a quick way to do it. Of course, you can go check it against the key to make sure it was correct, but let's just verify real quick. So I start at the origin, I move 8 over, 2 up, bam, I hit my function. That's a great indicator that you did the math correctly. Again, if you moved, 6 over and down 4, then something definitely went wrong. So I moved over 8 up 2. I'm pretty confident that that's the correct answer. So that is 1/4 of the way between B and A. All right. Keep going. Find the midpoint of line PQ. So for number 17, the midpoint of line PQ. Again, just visually, this is what's going on. I've got a point P, a point Q. Point P is at 3,5. Point Q is at -2,13. I want to find the midpoint between those 2 points. Remember, we gave you a formula back at the beginning. You add the 2 x's together, divide it by 2 to get the x value of your midpoint. You add the 2 y's together, divide it by 2 to get the y value of your midpoint. So here we go. Let's apply it. My 2 x values, doesn't matter what you're doing first, 3 plus -2 or -2 plus 3. It's the same thing when you're adding. So 3 plus -2. And then my 2 y values, 5 plus 13. If I simplify that, what do I get? 1/2. 18 divided by 2 is 9. So the midpoint between those 2 points would be 1/2, 9. Same thing with 18. Let's go ahead and set that one up. I won't draw another picture just because now you know what's going on. My 2 points are -2, 2.5 and 1.4, 4. So my midpoint is at -2 plus 1.4 divided by 2. And my y value is at 2.5 plus 4 divided by 2. So -2 plus 1.4 is -6. I'm sorry, -0.6 divided by 2. 2.5 plus 4 is 6.5 divided by 2. So we can simplify this a little bit. Take your calculator, type that in. That's totally fine. -0.6 divided by 2. And in fact, I think that's exactly what I will do. Take my calculator. 0.6 divided by 2 is 0.3. I'm going to go ahead and write it like this. I always just want to write 0.3, but I should really write 0.3. That way it's easier to recognize that that's a decimal. I always just kind of squeeze in the decimal afterwards, but I really should write it like that. Either way, as long as you catch the decimal, you're good. Same thing with 6.5 divided by 2. Take your calculator, type it in, but that's going to be 3.25. So that point is halfway between the two given points at the beginning of the problem. Next one's going to be a little more difficult, right? The first one was just kind of integers. Second one had some decimals. The third one's got some fractions. So don't freak out though, same method. My 2 points are P, 4 1/3, 3 1/6. And then, so this is P. And then Q is -2 1/5, 3 2/3. Want to make sure I'm writing this down right. Yep. So my midpoint, I'm going to add the two x values together. 4 1/3 plus -2 1/5 divided by 2. Add the two y values together. 3 1/6 plus 3 2/3 divided by 2. So if you're a little rough with fractions, maybe go back and watch a video how to add fractions, right? If you want to type in the calculator, that's totally fine. If you want to switch them over to improper fractions and add them together, that's cool too. I think I'll just kind of push through this and muscle through it. But again, whatever you need to do. If you need a calculator, that's fine. If you need to go back and review how to do it, that's cool too. If I add these together, of course, if I add them, I have to have a common denominator. So let's go ahead and flip them over to improper fractions just to kind of emphasize that. 4 1/3 is the same thing as 13/3. -2 1/5 is the same thing as -11/5. Comma there, that's a comma. 3 1/6, that's 19/6. 3 2/3, that's 9, 10, 11/3. And now you can kind of see how these denominators have to be the same. So let me write out another step. In order to have common denominators here, I think the least common denominator is going to be a 15. So I would have to multiply this denominator by 5, which means I have to multiply the numerator by 5. So that's going to be 65 over 15 plus, I'd have to multiply that by 3 to get 15. So I have to multiply that by 3. 33 over 15. Least common denominator here is 6. So 19 divided by 6, I'm good to go there. If I want to make that denominator 6, I'll have to multiply it by 2, which means I have to multiply the top by 2. And now I think I'm set up. So 65/15 plus -33/15, that's going to be what? 22. 32/15. 19/6 plus 22/6, that's 41. So 41/6. Let me just double check that math just because I initially made a mistake there. Yep, 32, 15, 15. Yep, perfect. And now I will take 32/15 and divide it by 2. If you don't remember this, 32/15 divided by 2 is the same thing as 32/15 times a half. So 32/15 times a half would be 32/30. 41/6 divided by 2 is the same thing as 41/6 times a half, which is 41/12. Well, I'm kind of getting crooked here on my screen. Sorry about that. I got to watch that. Now, I just want to simplify my fractions because you always do. You always want to simplify fractions. So this is going to be 16/15. Nothing. I don't think you can simplify at all. 41/12, right? 6, nope. 3, 4, nope, nothing. So I think that is the way I'd leave it. If you want to turn it back to mixed numbers, you can. Doesn't matter to me. So 16/15 is the same as 1 and 1/15. 41/12 is the same thing as 3 and 5/12. So either one of those is perfectly acceptable. Definitely a lot more work because it's fractions. So if you want to type that in your calculator, that might have been a better route. Okay, number 19 is done. Number 20, Cameron, Arthur, and Jamie are playing soccer. Their locations are recorded by a motion tracking system. The distance between grids is 5 meters. So when you see 10, 20, 30 at the bottom, that means, 50, 100, 150 meters. So number 20, how far apart are Arthur and Jamie? Round to the nearest tenth of a meter. Let me try to get us situated on here. How far apart are Arthur and Jamie? So there is Arthur, there is Jamie. It looks like Arthur is at 20,35. It looks like Jamie is at 45,20. And they want us to figure out how far apart they are, which means distance, right? Midpoint and distance are the two main things of this unit. So the distance formula is what we're going to apply here. So if you don't remember what the distance formula is, obviously, right, it tells you go back and see examples 3 and 4, or just flip back one page and remember they're giving it to you right in the concept summary. So the distance formula is the square root of, don't lose that, you got to have the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So let's go ahead and apply that. So I'm going to say that the distance is the square root of x sub 2. I'm going to call that my second point, that my first point. So that's going to be x sub 2. This is going to be x sub 1, which means that'll be y sub 2. And that'll be y sub 1. That's my first point, hence the 1. That's my second point. If you wanted to flip-flop it, it's the same thing. If you wanted to call that your first point, that's your second point, you get the same answer. Just make sure that both x and y are your first point. Don't call this x sub 1 and this y sub 2, and then it totally screws everything up. So x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. (45 minus 20 is 25. 25 squared is way beyond what I can do right now. 25 squared is 625. 20 minus 35 is negative 15. Negative 15 squared is 225. So if I simplify this a little bit more, 625 plus 225 is 850. And then the square root, that'll be your last step. Take the square root of 850. Square root of 850 is, so you could leave it as that. Personally, I would probably leave my answer as the square root of 850. There's a couple things you could do here, but we're not going to get into it today, and I don't even think we get into it in this class. You could simplify this radical. You could pull out a perfect square and simplify just the way it's written. Or if you want to rewrite it as a decimal, just type in your calculator the square root of 850. You can leave it as 29 point, I don't know, let's keep 3 decimal places. So 155. I rounded that 4 off. I rounded it up to a 5 because it's it's 0.1547. So that 7 makes that 3rd place round up 1 place. So either one of these is perfect as far as I'm concerned. So how far apart are they? Round to the nearest 1/10 of a meter. Of course, I can keep reading directions, and then it would tell me exactly how far to round it. Round to the nearest 1/10 of a meter. So that's my distance. What did they say? The distance between grids is 5 meters. So if I take that and I take 29.155 and I multiply it by 5, 29.155 times 5. So it's going to be 145.775. If they want nearest 1/10 of a meter, that's your 10th place. So it would be 145.8. All right, number 21, who is closer to Cameron? Explain. Visually, it definitely looks like Jamie. So, they're not saying you have to use math to explain it. Who is closer to Cameron? I'm looking at that picture, and unless I'm crazy, I would just say, well, Jamie is closer because she visually looks closer. But I think what they're getting at is they want you to use math, right? That's the whole point of all this. So let's go ahead and do that. Who's closer to Cameron? So I think what we just found is, nope, we didn't find Arthur to Cameron. So we're going to have to find the distance between both of those people to Cameron. So Arthur is at 20,35. Jamie is at 45,20. And then Cameron is at 65,40. So we need to use the distance formula, I think is what they're getting at, the distance formula between Arthur and Cameron and Jamie and Cameron, and see who's closer, right? So let's do Arthur to Cameron first. So the distance would be the square root of 65 minus 20 squared plus 40 minus 35 squared. (65 minus 20 is 45. 45 squared, 2,025. 40 minus 35 is 5. 5 squared is 25. So 2,025 plus 25 is 2,050. So from Arthur to Cameron, 2,050 units. Remember, each of those units represent 5 meters. So what I'm going to do is I'm going to type in my calculator, the square root of 2,050. I could show you actually what I'm doing here. The square root of 2,050, which gives me that. And all I'm going to do, just for the sake of keeping it simple, is multiply that by 5, because remember that's 5 meters per unit. So I'm going to call this oh crap. Let's do it again. 2,050 square root times 5. So I'm going to call this 226.4 meters. 226.4 meters. Okay, I did what? Arthur to Cameron, and now I'll do Jamie to Cameron. So Jamie to Cameron, square root. 65 minus 45 squared plus 40 minus 20 squared. So keep chugging along. The square root, 65 minus 45 is 20. 20 squared is 400. 40 minus 20 is 20. 20 squared is 400. So the square root of 800, just like I did before, I'll type in the square root of 800, and then I'll multiply it by 5 to get that distance. So 141.4 meters. So, we just verified what we already thought at the beginning. Visually, Jamie looked closer to Cameron, and then we can actually prove that by using the distance formula. So distance-wise, Arthur's that far away, Jamie's that far away. 22, the soccer ball is located at the point 35, 60. Who is closer to the soccer ball? So 25, 60. I'm going to use my Sharpie to point, but I don't want to make a mark. 25, 60. 25, 60 is right there. Don't draw on your book. I'm just doing it to emphasize. So there's our point right there, 25, 60. I'm sorry. Now I just realized I did 35. 35, 60. 35, 60. Now we got the correct point. Okay. So who's closer to that ball? Obviously, visually, it looks like Arthur is closer, but again, they want you to use the distance formula to prove that. So we're going to plug and chug and do the same thing that we just did. We're going to plug in everybody's stuff. So we know Arthur, we already talked about, is at 20, 35. We know that Jamie is at 45, 20. We know that Cameron is at 65, 40. And we know that the ball is at 35, 60. All right. So who's closer? Now it's just basically using the distance formula over and over and over again to prove who is closer. So since that's the last problem, I'm going to go ahead and get rid of this book underneath it. And then we will wrap this up. So here's our information. So distance formula, Arthur. So Arthur to the ball. So we'll call the ball 0.2. We'll call all of these 0.1, and we'll call the ball 0.2. 35 minus 20 squared plus 60 minus 35 squared. All right. If we simplify this, 35 minus 20 is 15. 15 squared. 15 squared, 225. 60 minus 35 is 25. 25 squared, 625. 225 plus 625 is 880. 850. Square root of 850. Square root of 850 is, I'll go ahead and show this so then I don't have to write it down. The square root of 850 is that. And again, each of these units is 5 meters. So we'll multiply that by 5, which we'll call 145.8 because we want to round that to the nearest tenth. So 145.8 meters. All right. Let's do Jamie, I believe it was. So Jamie, we'll set it up the same way. 35 minus 45 squared plus 60 minus 20 squared. 35 minus 45 is negative 10. Negative 10 squared is 100. You might wonder why some negatives, some positives. Don't forget, distance is always positive. That's why we're squaring these, because distance can never be negative. You're never going to walk negative 10 feet. It doesn't matter if you walk north or south, east or west, it's all 10 feet, right? So distance is always positive. 60 minus 20 is 40. So 40 squared is 1600. So that is going to equal the square root of 1700. Go ahead and show my calculator here. Square root of 1700 times 5, 206.2. All right, last one. I don't even remember. Charlie, I don't remember who C is, but here we go. So it's going to be 35 minus 65 squared plus 60 minus 40 squared. 35 minus 65 is negative 30. Negative 30 squared is 900. 60 minus 40 is 20. 20 squared is 400. So add those together, you get 1300. Square root of 1300 times 5, 180.3. All right. Let me go ahead and just flip the book back open because I don't remember exactly what it was asking us to do. So we're going to go back to 1.3. The soccer ball is located at the point. Who is closest to the soccer ball? So this represents all the distance those people are away from the soccer ball. So it looks like A, and again, who is A? You can tell my memory is just garbage. A is Arthur. Arthur is closer to the soccer ball, which again, visually we thought, but we need to prove it with math. So A is Arthur is closer, then Cameron, then Jamie.